law of motion. Describing motion. Speed. When we observe two objects that are moving, we can compare the speed of each object. The speed of an object can be found by determining the distance an object travels in a given amount of time. Speed equals distance over time. If you measure the distance in miles and the time in hours, the speed would be calculated in miles per hour, or miles divided by hours. If distance is measured in meters and the time is measured in seconds, the speed would be calculated in meters per second, or meters divided by seconds. When an object is not moving, its speed is 0. When one object is moving faster than another, its speed is greater than the first object. When one object is moving slower than another, its speed is less than the first object. When an object is at rest, its speed is 0 meters per second. When an object is in motion, its speed is greater than 0 meters per second. Describing motion, velocity. When a speed is reported with a direction, we call this velocity. For example, we could measure the speed of a box moving on a smooth surface as 10 meters per second. However, the speed does not indicate what direction the box is moving compared to other objects. If this were reported as 10 meters per second to the left or right, 10 meters per second to the north, or 10 meters per second downward, then we would have information about both the speed and the direction the object is moving, which means we know the velocity of the object. This object has a velocity of 10 meters per second to the right. Often, we will use positive and negative numbers to help describe direction. If an object is moving only left and right, for example, we usually use positive for motion to the right and negative for motion to the left. We do the same with up and down, positive and negative. That way, the numbers work exactly the same way as the coordinates in a Cartesian graph. Stop and check. What is the difference between speed and velocity? Describing motion, acceleration. When the velocity of an object changes, we say that the object is accelerating. Whenever a moving object speeds up, slows down, or changes direction, it is accelerating. When the object is not speeding up or slowing down, its acceleration is equal to 0. Remember, that does not mean that an object is no longer moving, it is just moving at a constant speed. When an object changes speed or direction, it has accelerated. Newton's second law of motion. In the first Explore Explain lessons, you learned that when all the forces acting on an object are balanced, the motion of an object does not change. If the object is at rest and all the forces acting on it are balanced, the object does not move. If the object is moving with constant speed in a straight line, constant velocity, and all the forces acting on it are balanced, then the speed and direction remains the same. Newton's second law of motion describes what happens when unbalanced forces act on an object. When unbalanced forces are applied to an object, the object accelerates. Two variables affect the acceleration of an object: the net force acting on the object and the mass of the object. Stop and check. When is an object accelerating? If an object is moving in a straight line at a constant speed, is it accelerating? Why or why not? Force and acceleration. Force and acceleration are directly proportional. When two variables are directly proportional to each other, if one variable increases, the other variable also increases. The opposite is also true. If one variable decreases, the other variable also decreases. For example, if you double the net force acting on an object of the same mass, the acceleration also doubles, as shown in the image from the simulation. The image shows force being applied to a 50 kilogram mass. When the force is increased from 100 newtons to 200 newtons, the acceleration is increased from 2 meters per second squared to 4 meters per second squared. Same mass, different magnitude of net force. Acceleration and mass. The relationship between mass and acceleration is different. The greater the mass of an object, the less it will accelerate when a given force is applied. For example, if you double the mass of an object, this results in only half as much acceleration for the same amount of force. This is an inversely proportional relationship. Same net force, different mass. Newton's second law can be represented by mathematical formulas. If you know two of the variables describing the motion of an object, you can use algebra to calculate the third. Formula in words, formula in symbols, description of formula. Formula in words. Acceleration equals net force divided by mass. Formula in symbols. A equals F net divided by m. You can calculate the acceleration of an object by dividing the net force acting on that object by the mass of that object. Formula in words. Net force equals mass times acceleration. Formula in symbols. F net equals m times a. Description of formula. You can calculate the net force acting on an object if you know both the mass and the acceleration of the object. Formula in words. Mass equals net force over acceleration. Formula in symbols. Mass equals F net divided by A. Description of formula. You can calculate the mass of an object if you know the net force acting on an object and the acceleration of an object. Units of measurement for Newton's second law of motion are in the following table. Measurement, unit, symbol, and description. Measurement, force, unit, newtons or kilogram meter per second squared. Symbol, Newton or kilogram times meters per divided by second squared. Description, force is measured in newtons or capital N. 1 N is the net force required to accelerate a mass of 1 kilogram by 1 meter per second squared. Measurement, mass. Unit, kilogram. Symbol, kg. Description, mass is measured in kilograms or kg using a balance. Measurement, acceleration. Unit, meter per second squared. Symbol, meters divided by seconds squared. Description, acceleration is measured in meters per second squared. Acceleration describes changes in velocity. Summary. Newton's second law of motion describes how force and mass affect acceleration. The law states that the acceleration of an object depends on the net force acting on the object and on the object's mass. Force and acceleration are directly proportional. When two variables have a directly proportional relationship, when one variable increases by some factor, the other variable increases by the same factor. Likewise, when one variable decreases, the other variable decreases. Mass and acceleration are inversely proportional. When two variables have an inversely proportional relationship, When one variable increases, the other variable decreases. Newton's second law can be represented by a mathematical formula. You can rearrange the formula to solve problems using algebra. Acceleration equals net force divided by mass. Note, like velocity, force and acceleration are vectors and can be negative. For example, for net forces and accelerations towards the left. The formulas work correctly. For example, using the formula for acceleration, if the net force is negative, that is to the left, the acceleration will be negative to the left as well.